Okay. I will first of all ask Momina Binte Noman, because I gave her question 6.5 on page 162. So I hope Momina is prepared. I will unmute her. Okay, Momina Binte Noman. Yes, Momina?
Assalamu alaikum.
Wa alaikum assalam.
Yes, I have prepared. Can I share my screen?
Yes, sure. Okay. Okay, yes, now you can.
Can you see?
Yes, yes. Yes, we can see your screen.
Okay. One of the ores of copper is chalcopyrite.
Okay, chalcopyrite.
Chalcopyrite. A laboratory analysis showed that 15.15 grams of chalcopyrite contained 4.61 grams of iron, 5.27 grams of copper. The only remaining element is sulfur. Calculate the empirical formula of chalcopyrite. Now,
Yeah, okay,
in this,
just a little correction. You see, when you say the decimal numbers, this is how you say it: 15.15, okay? 4.61. Like, you know, the digits that come after the decimal, you cannot call them, you know, 15, 61, or 27. Are you getting my point? So you have to say their names individually: 15.15, 4.61, 5.27. Okay, that's just a
yes.
little. Okay.
Okay.
Yeah.
So
Continue.
in this question, we need to find the amount of sulfur, because over here they have not told the amount of sulfur, and we
Right.
also need to find the empirical formula.
Okay.
So
Yeah.
to find out the amount of sulfur, we will look at the elements of the question, like what is it telling us? So it is telling that the total amount of chalcopyrite is 15.15 grams. And it also tells us that 3 elements make it up. It told us the number of 2 elements, what amount makes up the total of 2 elements of iron, which is 4.61 grams, and of copper, which is 5.27 grams. Now, of the 3 elements, we don't know what is for sulfur. So to find out sulfur, we will follow this formula: copper plus iron subtracted by total amount of chalcopyrite, which would be equaling the amount of sulfur. When we put in the numbers, it would mean 5.27 plus 4.61 equaling to 9.88, which will then be subtracted by the 9.88, which will be then subtracted by the total amount of chalcopyrite, which is 15.15, and we get the answer 5.27. So the amount of sulfur is 5.27 grams.
Okay.
We
So
found out.
So basically, let me summarize it for those of you who are joining, who might be joining us for the first time. So we are doing questions regarding the calculation of empirical formula, right? So we have to calculate the empirical formula of chalcopyrite, which is an ore of copper, right? In the question, they have given us the mass of iron, the mass of copper, and the total mass of the ore. And so we have to now calculate the empirical formula. Now, in order to calculate the empirical formula, we have to calculate the molar ratio. Now, in order to calculate the molar ratio, we have to know the number of moles of each element. So that's what Momina is doing. Okay.
So we have found the amount of sulfur. Now we only need to find out the empirical formula.
Right.
So to find out the empirical formula, first we need to convert the masses into moles using molar mass or atomic mass. So the formula is mass over molar mass. Right. For iron, it would be 4.61, which is the mass divided by molar mass or atomic mass, which is 56. So we get 0.08 mole of iron.
Right.
The same goes for sulfur, which is 5.27 over 32. And for copper, also it's 5.27 over 64. So for sulfur and copper, we know that because they both are the same numbers, we also know that their ratio in the total O is 1.1.
Right, right. So, okay.
So we need to determine which element has the smallest mole value, then divide all the mole values we calculated by the smallest value, which in this case is 0.08.
Right. So how the way you calculated the molar ratio was that you took the number of moles and you divided them with the smallest number that you had. And the smallest number was 0.08. So you divided all the three number of moles by the small to calculate the ratio, right?
Yes.
So you got 1:1:2, right?
Yes. So we
Okay.
get the final answer.
Yes. And
Which is
this molar ratio would be represented in the final formula, which is copper, iron, and then S2.
yes.
Have you written the final formula? Oh, okay.
Yes, it's here.
Okay. 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 Thank you very much, Momina. You worked hard. Okay. Jazakallahu khairan. Okay. Now, I'm starting my video. So the final formula looks like this. So the molar ratio of copper, iron, and sulfur is 1:1:2, which should be represented in the final formula. So copper, iron, sulfur, and you write a small 2 on the right lower corner. We don't write 1. So when we, it is getting recorded. It is. So when we do not have numbers here, that means the ratio is, it means 1. Okay. Zainab, Wasim, you are next. Okay, after your presentation, please kindly mute yourself back. Okay, Zainab, Wasim, are you here? Okay, I'm unmuting you. Okay, Zainab, Wasim has prepared question number 6.6 for us.
Miss, can I please share my screen?
Yes, you are allowed. Yes.
Thank you.
So in this question, she is trying to calculate the empirical formula of antifreeze.
Miss, can you see my screen?
No. No.
Oh, 1 second, Miss.
So in this question, we will be calculating the empirical formula of antifreeze, which contains carbon, hydrogen, and oxygen. Okay, in the meanwhile, to save time, I'm just reading the question. Okay, just to save time. A sample of antifreeze has the composition by mass 38.7% carbon, 9.7% hydrogen, and 51.6% oxygen, right? Now, percent means out of 100. So this is the ratio of mass. So this is out of 100. Oh, Zainab, are you having problem? Okay, maybe because my video is on. Okay, I'll try to shut my video and then you try one last time. Otherwise, then I will explain. And if you cannot, then just let me know through the chat window that so that I can go ahead and explain them. Okay, okay, it's okay. So so they gave us the mass in percentages. Now percentage means out of 100. Okay, so using this mass ratio, we can use these values for mass. Okay, we can use these values for mass. Okay, so I solved this question. So the first is, okay, Zainab. Yeah, okay, now we can see your screen. Zainab, we can see your screen now. Do you want to do it? Okay, I am unmuting you again because I can see your screen. So let me unmute you. Yes?
Yes, Miss. I want to
Yeah.
answer them.
Okay.
Okay, my first question was, a sample of antifreeze has the following composition of mass. Carbon, which is 38.7%, hydrogen, which is 9.7%, and oxygen, which is 51.6%. We have to calculate its empirical formula. To calculate the empirical formula, first we have to convert all of the values from percentage into grams. If we add all of these three values, they give us 100%, so we can convert them easily into grams. So 38.7% of carbon would be turned into 38.7 grams. Then we
Right.
will divide each of the values by its mass number, which is found on the periodic table. So
So
38.7.
why do we divide by the mass number? Please explain. To calculate what?
To calculate its
Yes.
mass.
What do you get? See, mass is already given. You just converted percentage into grams, right? So your grams is mass. So when you are dividing that by the molar mass, right? What are you calculating? You are calculating
The elements mass.
the number of moles, right? Because that's what you want to calculate the empirical formula, right? You want the molar ratio,
Yes.
right? Yes.
Yeah.
Yeah, so we are dividing by the mass number because we are trying to calculate the number of moles, right? Because empirical formula is what? Empirical formula is a formula that tells us the smallest, simplest whole number ratio that the elements exist in a compound, right? Okay, continue. Yeah, so see, just a little interruption. You know, I am more interested in you guys explaining clearly, absolutely clearly. I mean, you have to give me reason for each and every step. I don't mind if you don't make slides, okay? I don't mind that at all. But what I expect from you guys is that you give me explanation behind each and every step and explain it like openly, like, right? Okay. So yeah, you've done a fabulous job. Okay, continue. So mass number can be taken from the periodic table, and
then we're going to divide all of the values we've got by the smallest value. Over here, it's 3.23. Then we get the numbers 1, 3, and 1.
And so why are you dividing by the smallest value? She did not? No, she did. So yeah, so this 3.23 is the number of moles. Okay, so the number of moles is 3.23 for carbon. Okay, and 9.7 is the number of moles for hydrogen, and this 3.23 is the number of moles for oxygen. And so you have to calculate the molar ratio, right? So in order to get the molar ratio, which has to be simplest, smallest, and whole number, so you are dividing all the three numbers by the smallest number, and the smallest number here is 3.225. I mean, what, 3.23. So by dividing all the three number of moles by 3.23, you got a ratio of 1:3:1.
Yeah.
Yes. Yes. Okay. And so our formula is?
So our formula is CH3O.
Yeah. So 1:3:1. That means 1 carbon for 3 hydrogen atoms and 1 oxygen atom. Okay. So this was part A.
Part 2 was the relative molecular of the compound is 62. What is its molecular formula? In the question, they've already given us they've already given us the molecular mass. We have to calculate its empirical mass. And normally we have to calculate the empirical formula, but since in the first part we already did, we're going to take those subscripts and multiply them with their mass number to try to find out their empirical mass. So again, 1 would be multiplied by 12, 3 by 1, and 1 by 16. Then we're going to add all those values, and we get 31. Now to find the molecular formula, we will divide the molecular mass by the empirical mass, which is 2. Now this number, we would multiply it with the subscript of the empirical formula, and that will give us our molecular formula.
Okay. Okay. Last part, C.
This compound is a diol. The molecules contain two alcohol OH groups attached to different carbon atoms. This is what I think that you asked me to find a structural formula. This is what I think it would look like.
Okay. Yeah, you're correct. Yes. 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 Thank you very much, Zainab. Jazakallah khairan. Okay. You did a wonderful job. Okay. Now mute yourself. And so, okay. So this is how Zainab did her, this was the empirical formula. This is how she did the B part, which is molecular formula. Okay. So this was the empirical formula that we calculated from part A. So I hope all of you understood how that empirical formula was calculated. And so we want to find out what the molecular formula is. And the question tells us that the molecular mass is, okay. Yes, Hala, I'm going to answer that in a while. Okay, so the molecular mass is this, right? Now, I assume now, because I don't know the molecular formula, so I gave this. So empirical formula is the simplest ratio of the atoms. Now, so that means molecular formula, if empirical formula is the simplest, that means molecular formula should be some multiple. Molecular formula should be some multiple of the empirical formula. Multiple means like, you know, the mass that you are getting, which is the empirical mass, the mass that you will, what is empirical mass? The mass that you get using the empirical formula multiplied by some number that we don't know should give us the molecular formula. Okay. So this is what I mean when I say empirical mass is the multiple of molecular mass or molecular formula, both. Okay. So I assume that it is X because I don't know. Okay, so mass of carbon is 12, 12x. Mass of one hydrogen atom is 3, so 3x. Mass of one oxygen is 16, so 16x. Total should give me 62 because that's the molecular mass given in the question. Now I added all of them up and I got 31x is equal to 62. So it is clear that empirical and molecular formulae are not the same. Otherwise, their masses would have been the same. And I can see that this is 2 because when I divide 62 by 31, I'm getting 2. So that means this is 2. This x that I assumed initially, it is 2. So now I will multiply everything by 2. Right. So now C2, okay. Hydrogen is 3, 3 2s are 6, hydrogen is 6, oxygen 2. Okay, C2H6O2. Okay, so that's how we figured out what molecular formula is. So you should know either the empirical formula or you should know the empirical mass, and then you can find out the molecular mass if you know what multiple is it. Okay, is it getting multiplied by 2 or 3 or 4 or whatever. Okay, now how did we find this structural formula? Now this is the structural formula, same as Zainab showed us. Now how did we figure this out? Now the question says, pay attention to the question. The question says that this compound is a diol. I hope the screen is clear, and if not, then you can refer to your pages or the PDF file that I sent. Okay, so this compound is a diol. Now you guys have not done, yeah, so this, it's okay. So you guys have not done the naming for organic compounds, hydrocarbons. Diol, all means, all is used for hydroxyl, hydrocarbons that have hydroxyl groups, alcohols. All is for alcohol, okay? All is for alcohol. So hydrocarbons that have OH, they belong to the alcohol family, the all group. Okay, you have not done this in detail. Inshallah, we will do it in 9th grade. But just for this purpose. So all is the suffix that that comes at the end of the names of this family that has hydroxyl group. Hydroxyl group is OH. Okay. Now diol, di means 2. Di means 2. Okay. So we know that there are 2 hydroxyl groups and there are 2 carbons. So how did I make this? I'll tell you how I made this. So I know the molecular formula. It is C2H6O2. Okay. Now there are 2 carbons. So I drew 2 carbons. Okay. And the question tells me that there are 2 diols, 2 hydroxyl groups. So hydroxyl groups are always bonded to carbon atoms. So I added this. Okay. So now how many carbon atoms? 2. 2 oxygen. So 2 oxygens are gone. There is no other oxygen. So I know I'm done with oxygen. Hydrogen, I have added 2, 2 more, 6. Total are 6. So 4 more, right? 6 minus 2, 4. So that's easy. 1, 2, 3, 4. So this is my structural formula. So use your common sense a little bit, and then you should know that all is a family name for alcohols, meaning hydroxyl groups, and hydroxyl groups always bind to carbon. So yeah, a little of organic chemistry background was needed here. That's okay, that's fine. Okay, I cannot tell beforehand whose turn it would be. Okay, Atika, do you want to do it right now? If you want to do it right now, then you can do it. But I would want to do the book questions first. Okay, Atika, what I can tell you is that I will let you, I will give you a chance like after 2 to 3 participants. Okay. Okay, Nabil. Why didn't you write OH? You wrote HO instead. Very good, Hala. Very good. Yes, that's a good question. Why did I write OH? Because only oxygen can have 2 bonds. If, for example, I had written HO, what would that show? That hydrogen is having 2 bonds? That's not possible. And oxygen is not having any other bond. That's not going to happen, right? So hydrogen can only have 1 bond, right? Hydrogen is +1. So it is oxygen and then hydrogen. Okay. Did you understand that? Amra, Javed, you also had the same question? Yeah, did you understand? Okay. Is it important for EF to be the twice of MF? No, no, that's what I've been telling you, Amna, that the empirical formula can be any multiple. It can be multiple of 2, 3, 4, 5. So that's our job to find out with the help of calculations. Okay. 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 Okay, Syed Nabil. Okay, okay, let me stop the video. It's okay. Yes. Yeah, whenever I take your name, raise your hand, because you see, when you raise your hand, you come at the top. And so it's easier for me to unmute you. Yeah, that will save everybody's time.
Can I share my screen?
Yes, sure. So Nabil will be discussing question number 2 on page 171. For those of you who have the book.
So here it is, and the question was, the equation below shows how the fertilizer ammonium sulfate is manufactured. So part A was easy. Write a word equation for this reaction. So ammonia plus sulfuric acid gives us ammonium sulfate. And
Right.
how many hydrogens atom are there in the formula for ammonium sulfate? And there are 8.
Okay, you know what? When you write chemical equation, there's one little mistake that you should put an arrow not equal to sign. I understand maybe in PowerPoint you don't have that option, so yeah, but mention it. Okay, ammonia plus sulfuric acid, arrow, and then ammonium sulfate, not is equal to. And how did you calculate that there are 8 hydrogen atoms, Nabil?
Yes,
You
16.
just gave the answer.
Yes,
You
16.
gave the answer. You got to explain. Yeah, thank you. 16?
Yeah. So
How come?
6. I'll explain.
Are you
So
telling me?
I'll explain that. So 2 and here 3, 6 and 2 here 8.
No, 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 no. Nabil, the question is asking how many hydrogen atoms are there
Okay.
in the formula. You're confusing yourself. It's okay. It's okay. How many hydrogen atoms are there in the formula for ammonium sulfate? So we're only talking about ammonium sulfate, right? So only concentrate on the formula of ammonium sulfate. Look at ammonium sulfate formula. Look
Yeah.
at it.
So
Yeah,
this
okay.
this one
So yes.
4
So
into
now
2
tell
is
me.
8.
Yes, 8. So 8 is correct. So how did you get it? Just explain, in briefly.
Like H is 4 and the whole 2. So we'll multiply 4 with 2 and we'll get 8.
Right. That means there are 2 ammoniums, right? So each
Yes.
ammonium has 4. So total, you are adding
8.
4 twice, or same thing as multiplying, right? Okay. Move on.
So part C was what is the formula mass of sulfuric acid?
Right. So first we will look at the formula of sulfuric acid. It is
It's H2.
H2SO4. Okay.
Yes.
So what does that formula tell us? That there are
2 hydrogens.
atoms in one molecule and
Yes.
1 sulfur.
1
Yes.
sulfur and 4 oxygens.
Very good. 4 oxygen atoms. Okay.
Sorry, 4 oxygen atoms. Yes.
Right.
So 32 is for sulfur.
Okay.
And
Now go in a sequence. Go in a sequence from left to
2
right.
hydrogen.
Right.
1 hydrogen for 1. So 2 hydrogen plus 32
Right.
for 1 sulfur and
Very,
4
very good.
oxygen. So 16 into 4. So that gives
Yes.
us 98.
Right. So 16 into 4 is 60 into 4 is 64. 64 plus 32 is 96. 96 plus 2 is 98. So
Yes.
98 is the molecular relative formula mass for sulfuric acid.
Sulfuric
Right.
acid. So part D. In this reaction, 17 grams of ammonia produces 33 grams of ammonium sulfate. What mass would 3.4 grams of ammonia produce? So first of all, we would take that how much 1 gram produces. So to do that, so it's important that we take out that how much 1 gram produces. So we can multiply the amount we are given with. So if to take the 1, so we'll divide the whole with the single element given. It will be 33 over 7. That gives us 1.94.
Okay.
Then 1 gram, so 1.1 gram of ammonium equals 1.94 grams of ammonium sulfate. So 1.94 multiplied by 3.34 because it's given here, and that equals 6.48.
Okay.
That's it.
So, okay. So is that your final answer? Okay. Okay.
Yes.
So Nabil, you're done?
Yes, I'm done.
Okay. Okay. Thank you very much. Yes. Jazakallah khairan. Yes, it was a good effort. Okay. Now mute yourself. And okay, just a little detailed explanation of what just Nabil did, only of the last part, only of this part D. In this reaction, 17 grams of ammonia produce 33 grams of ammonium sulfate. What mass would 3.5 grams of ammonia produce? By the way, we have not done this. I have not explained this to you guys. Yeah, this was by mistake. I am sorry about that. I don't like giving questions from topics that I have not explained. So maybe we can, do the explanation first, but, Nabil has already explained. So let me just explain my way, for those of you who might not have understood. Yeah, it's fine. It's fine. Your answer is correct. Just, for detailed explanation. So for solving questions like that in which you have to find masses, or, any question regarding molar ratio, the first step is to write a balance equation. Okay, this balanced equation is already given in the question. It was already given in the question, so we can use this same equation here. And so and remember, the coefficients in the equation always give us the molar ratio. And when we do not write any number, it's understood that there is one, right? We all agree with that. And these coefficients, what are coefficients? Coefficients are these numbers that I write on the left side of the formula. Okay, not these small subscripts. These small subscripts are an entirely different story. Okay, they represent the number of atoms within one molecule. And these give us the number of moles, or the ratios of the number of moles. So the molar ratio is 2:1:1. Okay, following the coefficient of the balanced equation, and make sure that the equation is completely balanced. Now, looking at this ratio, and what are they asking? They're asking us the mass of ammonium sulfate given the mass of ammonia. So they have given us the mass of ammonia. They're asking us to find out the mass of ammonium sulfate. So try to understand the question. This is what they are asking. Now, looking at this molar ratio, we know that for whatever the mass of ammonia might be, half of it, I mean, not the mass, but the number of moles should be half, right? 2:1 of ammonia and ammonium sulfate. The ratio is 2:1, which is 1 is half of 2, right? But before you jump on and use this molar ratio, they have given you another piece of information. And that is that 17 grams of ammonia produce 33 grams of ammonium sulfate. Now, the fact that they have written this tells us that maybe the molar ratio is not being obeyed in this question. So we double check. Okay, we double check. How? So I first of all calculated the number of moles of ammonia. Okay, so mass divided by the molar mass. That is 1 mole. So according to this ratio, the number of moles of ammonium sulfate should be half of 1, right? It should have been half of 1, which is 0.5. But it happens that when I calculate the number of moles of ammonium sulfate by dividing the mass by the molar mass, and the molar mass of ammonium sulfate is 132. Okay, I hope you know how to calculate the molecular mass. Okay, I added the mass of each atoms and I multiplied them with their numbers. And so I got this 132 grams. And when I divided this mass, which was given in the question 33, by its molar mass, I got 0.25. But I was expecting 0.5, considering that the ratio is 2:1. So this should have been 0.5. But no, the molar rate, this number of moles is 0.25. What does that mean? It is less than what I was expecting, right? It is less than what I was expecting. So that means some reactant is getting wasted. Maybe ammonia is getting wasted because it is in the gaseous form, but some gas is getting wasted. Okay, we will talk about this in detail later. I'm just trying to solve this question for now. So again, so I will use this information. So I know that the number of moles for ammonium sulfate is 0.25. Okay, so if I know the mass of 1 mole, I will just simply multiply. Okay, now, so first I calculate the number of moles of ammonia, because the number of moles of, because the question is asking what mass would 3.4 grams of ammonia produce. So how many moles is that? I have to first calculate that. How many moles is ammonia? So again, mass divided by the molar mass. The molar mass of ammonia is 17. So I divide 3.5 by the molar mass, which is 17, and that gave me 0.2 moles. Okay. So now I'm using, so if 1 mole is giving me 0.25, 0.2 moles would give me, so this is the ratio method. Hala, you were asking for the ratio method. Please do not start your sharing. Okay, I will have to turn this off. Okay, do not start sharing your screen. Okay. Okay, so if the 1 mole is giving me 0.25, then 0.2 moles would give me, so I'm cross multiplying 0.2 by 0.25 and that many moles of ammonium sulfate. So once you have the number of moles, okay, you can simply multiply that by the molar mass to get 6.6 grams, which is the answer for the mass of ammonium sulfate. If you did not understand this, don't worry, okay? I will do this again after I have explained this, okay? I did not explain this before. I am sorry about that. Okay, next. Let me see who's next. Atika, you wanna come? Hania, you wanna come? Anybody can come. Okay, let me give a chance to Hania. Okay. Yes, Hania. I have unmuted you. I'm trying to unmute you. Yes, Hania. Is there any problem? Okay. Okay, fine. Let me ask somebody else. Yeah, okay.
The screen sharing option, there's
Yes,
a bit of a
okay, okay.
technical error over
Yes,
there. So could you
yes.
please share the picture I sent you?
Oh, you want me to share the screen?
Yes, miss.
Oh, okay, then I will turn that off. Okay. Okay, I'm sharing my screen. Yes. So you wanna solve this question first?
Yes. Or
Yeah.
should I solve the previous picture I sent?
You know what? This is very blurred. I cannot make out. Okay. Do you have this question in front of you?
Yes, miss, I do.
Okay, so let me share a clearer version. This,
Okay,
right?
miss.
Yes, because you know this is clearer. Okay.
Okay, so the one about moles is question 4B, the third part. It
Okay.
says a mineral of the type FeSO4.XH2O contains 37.2% of water.
Right.
Complete the calculation to determine X. They give us the mass of 1 mole of H2O, which is
Right.
18 grams. So this is basically the molar mass of 1 of H2O. And then in the second line, they say they've given us the mass of water in 100 grams of FeSO4.XH2O, which is 37.2 grams. And now
Right.
they're number of moles of H2O in 100 grams of FeSO4.XH2O. So basically, all we have to do in this is apply the formula of moles, which is moles is equal to mass in grams divided
Right.
by the molar mass.
Right.
So the mass in grams is 37.2 as they gave us, divided
Right.
by the molar mass of H2O, which is 18. So the
Right.
answer is 2.07.
Right. Yes. Yes. Okay.
The next one is mass. They're asking us the mass of FeSO4 in 100 grams of FeSO4.XH2O. And so basically, all we have to do in this one is subtract 37.2, the
Right.
mass of H2O from
Right.
100, the total mass, and then thus we get the mass of FeSO4, which is 62.8 grams.
Very good. Very good. Yes. Yes.
In the
And
next
so,
line, they give us the mass of 1 mole of FeSO4,
which is 152 grams. So basically, this is the molar mass of FeSO4.
Right.
And then they're asking the number of moles of FeSO4 in 100 grams of FeSO4 dot XH2O.
Right.
So we have to divide 62.8 grams, the number we gave in the previous blank, which is the mass in grams, divided by 152, which is the molar mass. So and the answer we get is 0.41.
Right. Okay.
And in the next one, they're asking us what is X equals to, the X in FeSO4 dot XH2O. And to get X, all we have to do is divide 2.07 by 0.41. The 2.07 is the number of moles of XH contained in XH2O, and 0.41 is the number of moles of FeSO4. So all we have to do is divide 2.07 by 0.41 and we get number 5. So X is equal to 5.
Okay, so okay, let me check this and divide it by 0.4. Yes. Okay, so you use the ratio method in the last step, right? So
yes,
so 0.4 was the mass of FeSO4?
Yes, 0.41 was the mass of FeSO4, the number of moles.
Right, and 2.07 was the
number
mass
of moles
water.
Yeah.
Right. Okay, I'm sorry about this. What happened here? Okay. I'm sorry about this. Okay, so I hope you guys understood this. Okay, then next question. What was the next question that I gave you? This was the only, right? Anya? Yeah, okay, now let me see. Quantities of chemicals expressed in moles can be used to find the formula of a compound, to establish an equation, and to determine reacting masses. Okay, Hania, just do part A and B of this question. This is question number, are you muted? How did you get muted? Okay, I have unmuted you. Yes, Hania?
I'm unmuted.
Yes, okay. So just do the first two parts, okay? Don't do the third part, because I haven't explained that as yet.
Okay.
So Hania is doing question number 4 in your books, page 172. Do you want me to show them?
Yes, Miss. Could you show the blank where I have the page with me, so.
Okay. So I'll just start my video. I'll start my video because I don't have a picture of this. So this question number 4, page 172. Okay. Quantities of chemicals. See, this is a voluntary class. People are, Sayed, you can leave whenever you want, okay? It's absolutely fine. Okay. Don't have to ask me. You can leave whenever. Okay, quantities of chemicals expressed in moles can be used to find the formula of a compound, to establish an equation, and to determine reacting masses. So part A, a compound contains 72% magnesium and 28% nitrogen. What is its empirical formula? Okay, Hania.
Okay, a compound contains 72% magnesium and 28% nitrogen. What is its empirical formula? So first of all, to find out the empirical formula, we take magnesium and we need to find out the number of moles it has. So we apply the formula moles is equal to mass over molar mass. The mass of magnesium, if you subtract 72 from 100, is 72. And if you take the 72% magnesium, so it's 72 divided by 24, which is its molar mass.
Yeah, so because, you know, the mass is given in percentages. Whenever the mass is given in percentages in questions, you can take that as mass itself. because they have given you the ratio, and ratio is all what you want. Okay, so just use that percentage and consider it as the mass, because everything will add up to 100. Okay, so you can just directly take it as the mass and then divide it by the molar mass, and the molar mass for magnesium is 24, so 72 divided by 24.
And then we get the answer, which is 3. And for nitrogen, moles is again we apply the formula, moles is equal to mass over molar mass, 28 divided by 14, which is its molar mass, and we get the answer 2. Now if the answer were in decimals, then we'd have to change it up a bit to get a whole number. But since all the ratio is 3:2 and both of them are whole numbers, we won't need to do anything, and so simply we write Mg3N2.
Right, right. I like the way you're explaining. Yes, good job. See, so the numbers are already in the simplest whole number ratio, so we don't need to divide them anymore. So 3 and 2 are already simple. Okay. Part B. A compound contains only aluminum and carbon. 0.03 moles of this compound reacted with excess water to form 0.12 moles of aluminum hydroxide and 0.09 moles of methane. Write a balanced equation for this reaction. So, okay.
We need to write a balanced equation for this reaction. So first of all, we write what we've been given. We've been given Al4C3 plus H2O, which reacts to give us AlOH3 plus CH4. Now we see how many aluminum atoms there are at the beginning. There are 4. So
no, but Hania, they did not mention Al4C3. Did they mention it? No. They just mentioned that the compound contains only aluminum and carbon. So we don't know how many, but okay, you use their oxidation state.
Yes.
Oh, okay. So carbon is 4 and aluminum is 3. Okay, okay.
So aluminum is AlOH3. We add, before aluminum, we add the number 4. And since carbon is also 3, so for in Al4C3, carbon, there are 3 carbon atoms. So in CH4, before C, we add 3. And we count, in the products, we count how many hydrogens there are, and then we add 12 in H2O, in 12 before H.
Okay.
And that's balanced.
So is that balanced?
Yes, miss.
Oh, okay. Okay, right. So the ratio is, so how did you use the ratio? How did you use the molar ratio? Can you repeat that a little?
I didn't actually use the molar ratio for this.
Yeah, but you have to,
Yeah, all I did was balance it, write it down, and then I balanced it.
Yeah, but that's not how, that's not the proper way of doing it. You might get the correct answer, but they want you to use the molar ratio, the moles that they have, mentioned. 0.03 moles of this compound reacted with excess water to form 0.12 moles of and 0.09. Okay, okay, I'll try to explain this. Okay, Jazakallah khairan, Hania, your explanation was wonderful.
Thank you, miss.
Thank you. Okay, let me. Okay, so let me try to get this. So what is the question asking? Write a balanced equation for this reaction. So if I write down the number of moles for each compound, this is what I got. So we have 0.12 moles of aluminum hydroxide, 0.09 moles of methane, and 0.03 moles of this compound. Okay, now if I want to find out the ratio, what do I have to do? I will divide all of these by the smallest number, and the smallest number here is 0.03. Right? Of the 3 numbers, the smallest number is 0.03. 0.03, 0.03. So what am I getting? 1, and this is, I'm using calculator, 0.12 divided by 0.03 is 4. I'm getting 4, and then this is 0.09 divided by 0.03, and this is 3. So the ratio is 1:4:3. And so, can we further? How did we do this? Okay, let me think on this. Okay, let me work this out myself. I did not get time to work on this question, and then we will discuss this in detail again. Okay. Okay, who's next? Okay, Yusra. Okay, Abdul Rahman. Okay, Abdul Rahman. Yes, Abdul Rahman.
Yes, ma'am. Screen share.
Yes. I have already allowed, I think. Okay. Yes, now you can.
Ma'am, can you see my screen?
Yes, Yusra, you can do after Abdul Rahman. Yes.
Ma'am, can you see my screen?
Yes, yes, I can.
Okay. Assalamu alaikum wa rahmatullahi wa barakatuh. I am Muhammad Abdul Rahman Afzal from grade 8 Pisces. First question is, what is the relative formula mass of calcium carbonate, CaCO3? There are 4 options, 50, 68, 100, and 204. As you know that relative formula mass is the sum of masses of all atoms present in the formula. Relative formula, here we have 3 elements and 5 atoms in total in the total relative formula of CaCO3. So the weight of calcium is 40 and the weight of carbon is 12 and of oxygen is 16. As we have 3 atoms of oxygen, so we multiply 16 with 3. 16 with 3, answer is 48. Then we sum up all 3. 40 plus 12 plus 48 makes 100. So the answer is 100. Next question is the answer. I can tell you the answer. The answer was 100. Next question is, a molecule Z contains 2 atoms of oxygen, 6 atoms of hydrogen, and 3 atoms of carbon. What is the formula of Z? There are 4 options. Number 1, CH3, CH2, CHO. Number 2, CH3, COCH3. Number 3, C2H5CO2H, and the last option is C3H6CO2H. We have to see them separately. 2 atoms of oxygen, 6 atoms of hydrogen, and 3 atoms of carbon. So the first option was CH3, CH3, CH2, CHO. There were 3 atoms of carbon and 6 atoms of hydrogen and 1 atom of oxygen, but we needed 2 atoms of oxygen. So this is eliminated. The second option is CH3, COCH3. In this one, we have 3 atoms of carbon, 6 atoms of hydrogen, and 1 atom of oxygen again. So next is C2H5CO2H. In this one, we have 3 atoms of carbon, 6 atoms of hydrogen, and 2 atoms of oxygen. Last option is C3H6CO2H. In this, we have 4 atoms of carbon, 7 atoms of hydrogen, and 2 atoms of oxygen. 2 atoms of oxygen, 6 atoms of hydrogen, and 3 atoms of carbon is the answer C. C is the answer. So the option C is the answer. Next slide is. Next question is, 2 atoms of magnesium Mg react with 1 molecule of oxygen O2. What is the formula of the product? There are 4 options: MgO, MgO2, Mg2O, and Mg2O2. 2 atoms of magnesium is equal to 2 Mg. 1 molecule of oxygen is equal to O2 because 1 molecule of oxygen has 2 atoms. So 2 magnesium plus 1 oxygen is equal to 2 MgO. The formula will be MgO. So the weight of 2 2 magnesiums is 48, and the weight of the weight of the 2 oxygen is 32. So we will sum up 48 plus 32 is equal to 80. So only Mg2O2 has molecular mass 80, but we usually don't write same subscript like Mg2O2. Also, we know oxidation state of Mg is +2, which gets cancelled by -2 of oxygen. Magnesium is giving 2 electrons and oxygen is taking 2 electrons. Thank you.
Very good, Abdul Rahman. Very good. Yes. Yes. Jazakallahu khairan. You've done a wonderful job. You've done a wonderful job. Okay. Now mute yourself. So I hope everybody understood the last part of magnesium oxide. If you need further explanation, then let me know through the chat window. And if you have understood, then we will move on. Okay, Yusra? Okay, Yusra. Okay, Yusra. There are 2 Yusras, Yusra and Yusra Yusuf. Okay, I have unmuted you, Yusra.
Yes, Miss, I'm the one.
Okay.
Miss, I did not prepare the slides, so I did it on a copy. So can I open my video?
Yes, yes, sure. Yes.
Miss, it
Yes,
says that.
yes,
the
Amna,
host has-
you are after Yusra. Okay, Amna and Atika, you are after Yusra. Okay. Yeah, because we are running short of time, so keep it brief and real quick.
Miss, it says that the host has disabled me for opening the video.
Oh, I did allow. Participants. Oh, okay. Let me ask to start video. Okay, now try. Yes, okay.
Miss, can you see it?
Yes, I can see.
Yes. So, Miss, I got this question that a compound X contains carbon, hydrogen, and oxygen, and we have to find the empirical formula of this compound X, and they have given us how much mass each element contains.
Right.
So for finding the empirical formula, I did it in a different way, but I think I got the correct answer. I did it in the simpler way.
Okay.
So from 100 gram, we know that this much amount of mass of carbon, hydrogen, oxygen they have given us in the question. For the first step, I took the mass and then I divided it by the how many moles, and by dividing it by the moles over the molecular mass. So for the carbon, this 1 mole, and the molecular mass for the carbon is 12.01. So after dividing, I got the mole for carbon, which is 4.54. For hydrogen, I got 9.018, and for oxygen, I got 2.27. So after doing this, I then divided each answer by the smallest mole from the oxygen mole, as it is the smallest.
Okay.
So after doing this, for the carbon, I divided by the oxygen mole, which is 2.27. I got the answer 2. For hydrogen, I got 4, and for oxygen, I got 16. So this then the overall answer is C2H4 and oxygen 16.
Okay. So your question asked for molecular formula or empirical formula?
Empirical formula.
Empirical?
Yes, miss.
Yeah, but this is not the simplest ratio. Is this the simplest ratio? Yeah, this is not the simplest ratio. Okay. So how will you simplify it? So show me the answer. Yes, so C2H416. So can we divide them? So what you have done is you have divided the mass by the molar mass. Yusra, this question does not seem correct to me, but I need to verify. Did you divide the mass by the molar mass? Okay, show me the whole thing. Yeah, okay, so mass divided by the molar mass. So those were your moles, and then you divided by the smallest number. The smallest number was 2.27. So you got 2, 4, 16. Okay, correct. Okay, so what you have to do is simplify it. So how will you simplify? 2 1s are 2, 2 2s are 4, 2 8s are 16. So at the end you have C1H2O8. Did you understand, Yusra?
Yes, miss, I forgot the step.
Yeah, so this is molecular. This might be molecular. I'm not sure. Yeah, yes, Amina. You have to simplify the last answer. So it would be CH2O8. Write it down. Okay. Okay. Now part B. Part B
Miss, part
tells
B was
us.
related for the first part, so I got the first part wrong. So I did the second part with the same same answer for the first one.
Okay. 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 Or maybe we can do this tomorrow. In the next chemistry class. Okay. And you can correct it. Okay. You can correct it.
Okay, miss.
Okay. Okay. Amina.
Assalamu alaikum wa rahmatullahi wa barakatuh.
Wa alaikum assalam. You need to share or you need to show the video?
Yes, I'm sharing.
Amna Fatma, please kindly do not share your screen. It's Amna's job. It's Amna's turn.
Miss, it is me.
Oh, is that you? Oh, I'm so sorry. I thought Amna Fatma is somebody else.
No, it's me.
Okay.
So the first question I got was to find the insoluble salts that are made by precipitation. An equation for the precipitation of barium sulfate is given below. BaCl2 aqueous plus MgSO4 aqueous gives us BaSO4, which is solid, plus MgCl2, which is aqueous. The reaction can be used to find X in the formula for hydrated magnesium sulfate, MgSO4 dot XH2O.
Right.
A known mass of hydrated magnesium sulfate was dissolved in water. Excess aqueous barium chloride was added. The precipitate of barium sulfate was filtered, washed, and dried. Finally, it was weighted. And then we have to find the following. So first of all, the first thing we have to know is what is a precipitation reaction. So it is a type of reaction in which an insoluble salt and a soluble salt are produced, and they're produced by the reaction of two salts as well.
Yeah, it is not. It's not necessary that you should have a soluble salt as well. Precipitation is whenever you have an insoluble salt produced out of two soluble salts. Okay. Okay.
Yes. So then we can know by the state symbols that the one with the solid state is the precipitate as it settles down after the reaction, and we can also say this reaction as a displacement reaction, as chlorine is displacing the sulfate. But yeah.
Yes.
And then
okay.
For the question, the main thing was to find X in MgSO4.XH2O. So they told us that the known mass of MgSO4 was .H2O was dissolved in water, and excess barium chloride was added. So they gave us some information that mass of MgSO4 hydrated is 1.476. Mass of barium sulfate, which is formed, is 1.389, and the mass of 1 mole of barium sulfate is 233 grams. So mass of 1 mole of MgSO4, okay, we will discuss that later.
Okay, I would encourage all the participants to please attempt these questions on your own, because until and unless you don't do them on your own, you will not learn. Okay, so just attending class will not help. So kindly go ahead, solve the questions. Okay, if you have any problem, we can discuss in the class. Okay.
So we will be
Amna and Atika, I would request you if you could hurry up a little because we are running out of time.
Yes. So we will use this formula that mass is equals to number of moles into molar mass. So for the first part, they asked to find the moles, the number of moles of barium sulfate. So we can use a formula that mass divided by molar mass is equal to number of moles. So 1.389, as it was given in the question, we divided by 233 and we get the answer that is 0.006. Then the second thing they asked was the number of moles of MgSO4 hydrated. So we can use the ratio method that in the equation,
Right.
Over here, this like if we can see all barium and magnesium on both sides, their ratio 1:1. Over here,
Right.
like, so we can use that the same thing, and so it will stay at the number of moles is the same as barium sulfate, which is 0.006. And then they asked for the mass of the 1 mole of MgSO4 hydrated. So we'll again use the formula, and we got the number of moles from the previous part over here.
Okay.
Yeah, so we'll divide it 1.476 divided by 0.006, so we'll get 246 grams. And
Right.
then we have to find the mass of XH2O in 1 mole of MgSO4. So we can, like I wrote over here, that if we add MgSO4 and XH2O, we'll be getting MgSO4 dot XH2O. So we can do it the other way around, like if we subtract, we'll get one of them.
Right.
So over here we subtract MgSO4 hydrated minus MgSO4, so we'll get XH2O, the water part. So we know 246 by the previous question, and 120 it was given behind in the question, so our answer is 126 grams. Then they asked us to find X, the main part. So XH2O, when we divide it by H2O, we'll get X, because over here there's nothing in the middle, so it means they are multiplying. So we have to divide the mass of H2O, right? So we know from the periodic table that the molecular mass, the relative molecular mass of H is 1, and we have
Relative atomic mass. Atomic mass.
Relative atomic mass is 1, and we
Right.
have 2 atoms, so we'll multiply it by 2 and we'll get 2. And then
Right.
oxygen, we know from the periodic table that it is 16. So
Right.
when we add both of them, we'll get 18 grams of H2O. So we can divide 126 from 18 and we'll get 7.
Right. So that means 7 moles of water for each magnesium sulfate.
Yeah.
Right. Yes. I hope you guys understood this whole process, and you will understand it better if you do it yourself. Okay. And if you guys want, I can post these questions in the group. The questions that we are going to discuss, I can post in the group. The reason I don't post in the group is because I don't want to disturb you guys with messages. But if you are interested, especially the other students, if they will be better able to understand if they had the questions first, right? And then it would be easier for them to understand. Okay, Atika. Okay, Zainab, I will try to post the questions. Yes. Okay, Atika.
Miss, I have
Yes.
one more question, and then it's Atka's turn.
Yes, please ask.
Yeah. So the second part is the titanium ore contains 36.8% iron, 31.6% titanium, and the remainder is oxygen. This question we also did previously in the book.
Yeah,
Yes?
Amna, I would suggest that we do this in the next class, okay? Because it's already 8:18. So give Atika a chance. Okay, I'm so sorry about this.
No problem.
Yeah, because it's 8:18, and so.
Assalamu alaikum warahmatullahi
Wa alaikum assalam.
The first question is that iron forms an oxide with the formula Fe2O3. What is the relative formula mass of this compound?
Right.
So we have to find the relative formula mass. They gave us 4 options: 76, 100, 136, and 160. And relative formula mass of a substance is the sum of relative atomic masses of the elements present in a formula unit. It is also called as relative molecular mass. So we have to find the relative formula mass.
Right.
We have 2 atoms of iron, and the relative atomic mass is 56. So you multiply them both, and then we'll add 3 atoms of oxygen into its gram, which is 16, and we'll get the answer 160 grams per mole.
Right.
So the answer is D.
Okay.
The next question is that in athletics, banned drugs such as nandrolone.
have been taken illegally to improve performance. Nandrolene has the molecular formula C18H26 and O2. What is the relative molecular mass of nandrolene and relative atomic masses they have given us? And they give us 4 options. We have to find the relative molecular mass. We'll do the same thing. We'll multiply the number of their atoms by their RAM.
Right.
We have the RAM,
the relative atomic mass, or just the atomic mass, okay?
Yeah, and then the answer that we get is 274 after adding the all the sum when we take out the sum.
Right. Okay. 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 Jazakallahu khairan. Okay, then with this we will end the meeting, and inshallah in the next chemistry class we will do the reacting masses, how to calculate the reacting masses. Okay. Okay. Assalamu alaikum wa rahmatullahi wa barakatuh.